All right, what's happening, my mathletes? This is Mr. Muscarella coming at you, and in this video we're going to talk about solving trig equations, this time by taking square roots. So let's take a look at this, but before we do that, let's go ahead and review what that looks like. So there's going to be a little Algebra 1, Algebra 2 review coming at you. So I'm going to give you about 10 minutes to pause the video, do parts A, B, and C, and then also draw the unit circle and include all the tangent values. So about 10 minutes, off you go and get those three things done. See how quickly you can do it in 10 minutes or less. All right, so thank you, and I will see you momentarily. All right, how'd you do with that? Hopefully you got everything correct. Now the key thing on all of these, and this is the number one mistake, do not forget the plus minus. So make sure when you are doing that, you add in the plus or minus. Now another way you could complete each one of these is another way, and this is where another way you can look at the plus or minus. You could solve each one of them by factoring. I'll just do the first one here. If you have x squared and then move the 36 over, so minus 36 equals 0. And then that will factor, because that's a difference of two squares problem. So you'd have x plus 6, and then x minus 6 would be what that binomial would factor into. And then you get x plus 6 equals 0, so of course that one is going to give you negative 6. And then you have x minus 6 equals 0, so that would give you the value of positive 6. So that's another way you could do these, but the most efficient and effective way to do that is by solving each one of these by taking square roots. And on parts B and C, those ones are really nice because they work out to be perfect square numbers, both in the numerators and the denominators. So that's pretty cool. So on part B, you get plus or minus 1/5, and on part C, you get plus or minus 9/2. And hopefully you got your unit circle down and off you go to the races with that. So that is where we're rolling with for today. So same idea, and you'll want to start to recognize some patterns here. And the pattern that you want to look for is in the equation that you're solving, right? In the equation you're solving, there's one trig function, and that trig function is raised to the degree of 2. All right, so sine squared or cosine squared. So when we see that, or maybe it'd be an even degree in some other courses, but any even degree, you're going to want to, and it's only the trig function. So that means there's not a regular sine of theta. There's only a sine squared of theta. So as long as that's the case, the technique you want to use is solve by taking square roots. So first thing you got to do is get all the sine squareds in this one on one side. So I'm going to take this very first one over here on the right. We're going to move that over to the left side. So if you subtract sine squared from 2 sine squared, you'll just end up with 1 sine squared. But you don't write the 1, and you set that equal to 1. Now you want to always move things around so that the quadratic term, or the term that is squared, is going to be positive. So we've got that, sine squared equals 1. And then just like we did before, when you solve this, you'll have sine of theta equals plus or minus the square root of 1. And at this level, you guys should know the square root of 1 is 1. So sine of theta is going to be both positive 1 and negative 1. So sometimes when people separate, some people might separate that and go, okay, that's the same thing. So you could write like this, sine theta equals 1 and sine theta equals negative 1. Either way you write it, it is okay, it doesn't matter. What you need to do next is find the appropriate trig values, right? So now I got to go to the unit circle. And the unit circle, so let me pull that guy down here. So we're just going to bring you down, have you visit us over here. Cool. And then I got to look for the sine value to be 1 and negative 1. And that's going to occur at 2 spots. So sine theta is 1, so theta is going to be 1, where the y-coordinate is positive 1. So that is going to be all the way up here at that location. So that means for that value, sine theta being 1 is going to be at 90 degrees. Or if we write it in radians, that's pi over 2. So that's going to be, one of our answers right there. That comes from that piece. Now, the other spot is where sine theta is negative 1. So sine theta is negative 1. My y value is negative 1 down here at 270 degrees. So my other answer would be 270 degrees or 3 pi's over 2. And that's it. So you have to isolate the quadratic term or the squared term on one side, make sure it's positive, And then don't forget to take plus or minus the square root. After that, look for the values on the unit circle that work for that particular trig function. And that's all there is to this. So with that said, let's go ahead and take a look at example number 2. So let's move our little trig function over here out the way, get rid of these guys, and take a look at this one. So now here on this guy, we've got 3 tangent squared minus 1 equals 0. So again, we're going to move the 1 over. So we're going to have tan squared theta equals 1. I'm thinking ahead here because then we would divide by 3. So we'll do it step by step. So then some of you might be at that level at some point in your math lives where then you could divide by 3 and your very first line might be this. All right, tan squared theta equals 1/3. Now, taking the square roots of both sides, no big deal. Tan squared theta equals plus or minus the square root of 1/3. Now remember, when you have the square root of 1/3, you're going to kind of separate that. So you can kind of do this and say, well, that would be plus or minus the square root of 1, which we know is 1, so you don't have to write the square roots. That'd be 1 over square root of 3. Now, when that simplifies, because you got to go through and do all the rationalizing and all that stuff, so you'd multiply by square root of 3 over square root of 3, and then you'd get plus or minus square root of 3 over 3. So eventually, and this is one that I want you to have memorized, if you see plus or minus the square root of 1 over 3, then that's going to give you the value. Oops, I had the squared in there. Get rid of u. Forgot to, yeah, there we go. When you have that, you're going to make sure that you write tangent theta equals plus or minus square root of 3 over 3. So that's going to occur in a couple of different spots on the unit circle. So now, again, you know, same kind of idea. We just got to go hunting on the unit circle for where that is. So let's bring in our favorite friend here, the unit circle, and see where those spots are. See where those guys are going to be. So, oops, that should be an eraser. There we go. So let's bring in the unit circle. So now, plus or minus the square root of 3. So on my unit circle, I've got those change values already there. So that's pretty cool. So the positive version, so let's take a look at the positive versions first. So tangent of theta is going to be positive square root of 3 over 3 in a couple of spots. So let's highlight these ones in green, shall we? So 1 is going to be right here. So it's going to be a positive 1. And then another positive value is going to be right across from it. So the values on the unit circle that line up with, so let's go ahead and write these down, these first two. So theta is going to be 30 degrees. And it's also going to be 210 degrees. Now those same values in radians are going to be 1 pi over 6, or just pi over 6, and 5 pi, or 7 pi over 6. So those are two of my answers right there. So that is from the positive side. Now the negative side, so if tangent of theta is negative root 3 over 3, then the values there, so let's see, so theta would be negative root 3 over 3, so let's go with blue over here. So negative root 3 over 3 is going to occur right here at 5 pi over 6, or 150 degrees, or straight across from it, 180 degrees away at 330, or 11 pi's over 6. So again, I'll write down my two answers, 150 and 330 in degrees, and then that same answer in radians is going to be 5 pi over 6. As well as 11 pi over 6. So that's it. You just got to isolate the trig function by itself, find those values on the unit circle that correspond to it. Because remember, these are just the angle values, so it's almost like inverse trig. Like, what angle would solve this equation for us? So we're trying to find an angle that gives us a true equation here. And in this case, we've got 4 of them, 30 degrees, 210 degrees, 150 degrees, 330 degrees in degrees. And then also, likewise in radians, we've got pi over 6, 7 pi over 6, 5 pi over 6, and 11 pi's over 6. So that's it. That's all you got to do for this is take your time, don't forget the plus or minus, and then hunt on the unit circle and find those values. All right, I'll catch up with you guys later for the next one for examples 3 and 4, and I'll catch you later. Peace out.